free to, so that I don't feel that I'm just looking at the screen and talking. It doesn't matter if you have taken bath or not, however state you are in. I think it's fine. It's okay. So let me share my screen actually, and uh, so there would be a lot of things that what I'm going to discuss. A lot of people might already know. So I would request those people who would know the answer and who have seen this in the field already to just refrain a little bit from answering and let people who have joined recently to think about it and answer. And if they are not able to come up with the solution, then guys who know it already, who have seen it, please you can chime in. Okay. So before I discuss what the topic is, and many people might already know about it, but still, I do not want to reveal it. Before I start discussing about it, I had few questions for everyone that I want to post and asked what would be the answer for those. And then we will slowly come to what we are going to discuss. Okay. So this is the issue that I want to discuss with you. I have a couple of issues that I want to discuss. This is the first issue. So this is a VxLAN setup that you see here, where you have a spine and three VTEPs. Okay, and what you see here is that you have host one and host two that are communicating with each other. There is TCP traffic between host two and host three. Sorry, there's TCP traffic between host two and host three, and from host one you get a UDP traffic for host two. So let me just put a yeah. So from host one, you get like a 1 Gbps of UDP traffic that is destined to host two's MAC. Everything is in same VLAN say 10. All of them have their MAC addresses. ARP entry is already resolved. And then this H1 gets traffic for uh, VTAP, on VTAP 1, which is destined to uh, host 2. Okay. Just note that the communication has always been happening between H2 and H3. There has never been a communication between H1 to H2 or H1 to H3, apart from that ARP that got resolved in the initial phase of the communication. So this is a setup. Would anyone want to tell me what do you see in this setup, and what are the different observations that you have? Anyone? Let me know if the question is not clear. So H2 and H3 has been communicating, and H1 to H2 and H1 to H3, there is no communication so far. Just to give you a hint, when you have, so here you have VxLAN setup, right? And everything is static. So on on VTAP 2 and VTAP 3 and VTAP 1, you have the flutter statically defined, right? So if I look into the MAC address table of VTAP 2, what would I see? And same with VTAP 3 as well. What would I see? What MACs would I see?
All three MACs, H1, H2, and H3 on VTEP 2.
H1, H2, and H3 on VTAP 2, right? Correct. What about VTAP 3?
On VTEP 3, you'll see only H2 and H3.
H2 and
No, you will see H1, H2, and H3.
you would see H1, H2, and H3.
Yeah.
Correct. So on VTAP 2, you would see H2 and H3, and you said H1 as well. On VTAP 3 also, you mentioned H1, H2, and H3 you would see. What about VTAP 1?
VTEP 1 would have only H2
VTAP 1,
and H1.
how did VTAP 1 get H2 or H3?
No, because it has requested for, I mean, when the UDP packet from H1 lands on meetup 1, it
Okay.
would do an app request.
Oh,
Not
so yeah, here it's everything is in same VLAN.
oh, okay.
10, 10.1, 10.2, 10.3. There is no L3. It's pure L2 setup with
Okay.
every host in the same VLAN. So
Okay.
it's
Then meetup 1 would have just H1.
okay. So VTAP one would have only H1. Now,
Yes.
what would happen to the traffic that is received on VTAP one? There's 1 gig of traffic.
It will flood it to both VTEP 2 and VTEP 3.
Correct. So it would flood it to both VTAP 2 and VTAP 3. So
Hmm.
how much traffic? So what do you see is the problem here that is happening here, and how much traffic would go on the uplink interface in this interface?
2 GB traffic.
2 GB of traffic, right? That's absolutely right. 2 GB of traffic going on this link, though
Hmm.
only 1 GB was received, and 1 GB goes to VTAP 2 and VTAP 3, right?
Hmm.
So what is happening here? What is the issue that is happening that we see here?
Uh, we are sending traffic unnecessarily
Correct. You are absolutely right. We are sending traffic unnecessarily, and why are we sending that?
because we haven't learned the MAC address.
Because we have not learned the MAC address, right? So in this, yeah, you're totally right. In this setup, what we see is that VTAP 1 does not have the MAC address for H2 because H2 has never sent a traffic for H1. It's the communication between H2 and it's only communication between H2 and H3. And VTAP 1, we would never see the MAC address for H2 or H3. And every time there's a traffic that is coming on VTAP 1 for either of these hosts, it will flood it to all the VTAPs in the flood list, right? So there is an unknown unicast flooding that is happening in this network. Correct. And because of this, there is unnecessary bandwidth utilization, right? So this is what I wanted to, yes, you were right. This is what I wanted to discuss here. What we are seeing is that the MAC address table only has H1 on say Ethernet 1. Here you have all the three MACs. Here also, okay, I missed to put H1, but here also you have all the three MACs, and you are sending traffic unnecessarily and consuming the bandwidth, right? So why is this happening? Because the MAC address is not learned, correct? So what would be the solution for this? How, what can we do in such a case where uh, the MAC address is on, like let's say on VTAP 1, this is a MAC address H1. On VTAP 2, there is MAC address H2, and VTAP 3, there's MAC address H3, right? So what is causing the problem? The MAC not being there, right?
Yes.
So what should happen so that uh, Mac can be what should happen so that we don't see this issue?
Somehow VTEP 1 learns the MAC address of whatever is connected to the other VTEPs.
Correct. So we need to have this MAC address, but in such a scenario, the MAC can never be learned, right?
Hmm.
Because if you look at it, there's always a UDP traffic. And when there's a UDP communication between two hosts, like there is no acknowledgement, right?
Hmm.
So H2 would never say that, okay, I received the packet, right? Traffic could be anything, right?
Hmm.
That is received by H2. So in such a setup, right, how do we make sure that we are not unnecessarily utilizing the bandwidth, unless utilizing the resources? What can we do here? Uh, Anyone has any solution for it?
It's just 3 hosts and 3 VTEPs.
Yes, like as an example, there can be multiple.
Ah, okay. No. If it is just 3 hosts, I was thinking static MAC.
Good. That's definitely one of the option. But then the counter question would be, then how many hosts would we configure it,
Yeah.
right? And what if we move the host from one VTAP to another VTAP?
Mm.
What is the problem that you are trying to solve here, right? Uh, if you think about it, MAC not being learned, correct?
Mm.
So what would be solution for it? Like if you were given a chance to do something,
Advertise the Mac,
whose Mac where?
uh, the local host Mac to the rest of the VTEP.
Correct. The local host MAC to rest of the VTAP, right? So you're saying somehow exchange the MAC addresses. If I word it correctly or word it in a different way, right? You want the MAC to be advertised. So you want VTAP one to advertise its MAC to VTAP two, correct?
No,
You
the
want,
host Mac.
or you want, yeah. So VTAP one, you want VTAP one to advertise the host MAC to VTAP two, correct?
Yeah.
Similarly, VTAP2 to advertise the host MAC, which is the MAC address H2 that is connected to itself, to VTAP3 and VTAP1.
Yeah.
Basically, exchange their MAC address tables,
Yeah.
irrespective of whether the traffic has come or not. Right? And that's what. Yes, we need some kind of communication here, right? In a setup like what we discussed earlier, there is no way the VTAP1 would ever learn the MAC address of H2 because there's no communication from H2 to H1, right? And if we think about the basics of VxLAN setup where we have just static flood list and MAC address being learned with packets, you would H2 MAC would never be seen on VTAP1, correct? So you want some kind of communication between the VTAPs, VTAP1 and VTAP2, correct? Same goes with, you would want some communication between VTAP2 and VTAP3 so that they can exchange this MAC addresses, right? So if we are able to exchange our MAC addresses, whatever we have learned locally, then the problem resolves. We don't need to basically wait for a traffic to come in. VTAP1 does not need a traffic to come from H2 to learn the MAC address because VTAP2 itself can tell it to VTAP1, correct? So that's the idea of exchanging the MAC address between the VTAPs. Is that clear so far?
Yes.
Okay, great. Okay, so now we understand that we need to exchange MAC to overcome such situations, right? Now I have another scenario for you guys. So this is the issue too that I would like to discuss with you. So consider this: there is a DC where you have 64 VTAPs. Okay, so VTAP 1.1.1, 2.2, and so on till VTAP 64.64, right? And everything was working fine. The VDC was working in full capacity, but after a year, we just ran out of resources. There is no the servers that are connected does not have enough bandwidth, enough power to spin up more VMs or put more hosts, right? So then the proposal came to add another 64 VTAPs, right? So now what we need to do, we need to add 64 more devices here in the network. So the question is, can you think of this setup where you need to add 64 more devices and think what would be the challenge that you would face while configuring these VTAPs in the DC? Again, this is a static VxLAN setup where you have to configure everything, VNI, flood list, and everything.
Yeah, so I guess one would be that again we have to, for all the VTIPs we have to explicitly add, right, via CLI, or if you have someone with tool also, we have
When
to
you say
manually add them.
when you say all the VTAPs, do we also need to add something to the existing VTAP, which is 1 to 64?
True. Yeah, so even for the existing VTIP, we have to add the flood list, have to change the flood list there. And while doing so, like there could be some error, right? We could have missed something since it's almost like 128 VTIPs we had changing the same point.
Correct. You're absolutely right. Again, yes. So while we have to add the 64 new VTAPs and we have to configure the flood list on that 64 new VTAPs, at the same time we have to also reconfigure the existing 64.
First 64, yeah.
Yes, to add the new 64 VTAPs, right? So we are not just configuring the existing, like the new setup or new VTAPs. We have to also configure the existing ones as well. And you are right. There could be even a minute mistake could cause a lot of problem, right? So correct. So that's the observation here. So there's a configuration override, right? You have to configure the new VTAPs as well as the set of VTAPs which already are working properly, correct? And trust me, I think we have seen setups with 128 VTAPs, and it's not like it is not possible. I think Airtel or even Vodafone has a lot of VTAPs. So that is possible. And to make a matter worse, the flood list can be per VLAN as well, right? If you guys are aware, we can have flood lists for every VLAN separately, right? So think about some VLANs which might be there on VTAP 1 to 20, some VLANs might not be there, right? And like that, you just not have to configure the flood list, you have to configure it per VLAN as well. Make sure that there is no config mistakes, and which is really difficult, right? So this is a very hard problem to solve because just to give an example of one of the case, I think this happened 2 to 3 years back where we had a Airtel case and one VTAP pair did not have the proper flood list, and it took us, and I think they had 128 VTAP. It took us like 4 to 5 days to figure out what was the issue, because there was somewhere traffic getting black holed, ARP was not getting synced properly, something like that. So when the flood list is not proper, you would have a very hard time to figure out where the problem could be, because it would be one of those VTAPs where the flood list has not been configured properly, right? So again, what could be the solution here? What can we do here so that the configuration overhead that we are talking about can be eliminated? Just take some cases from the previous issue itself. So what did we do in the previous case when we had to make sure that the MAC is learned everywhere?
Advertise once again, like the flood list, the VTEPs, loopback IP advertise to the rest of the VTEPs.
Sorry, come again.
So the newly added VTEPs, we need to add a static flood list, right? So instead, we'll just advertise that these are the newly added VTEPs, and the rest of the VTEPs will just add them to their flood list.
Correct. So you need to basically advertise the newly added VTEPs. So basically, again, the same thing comes in here, comes here as well, right? You would want VTAPs to communicate with each other and exchange their information, right? When we say flood list, what is the flood list? The flood list would be the loopback IP addresses at 1.1.1, 2.2.2. So they need to say that, hey, my IP is 1.1.1. These are the VLANs that has been configured on me. What about you? VTAP 2 would say that, hey, my IP is 2.2.2. These are the VLANs that has been configured on me, and so on. If they can exchange this information with each other, they can somehow dynamically configure the flood list, correct? This is only possible if VTAPs can talk to each other, right? And exchange this information. What information it is? The loopback address and the VLANs that has been configured on the devices. So yes, that's the solution for the second issue that we see here, the configuration override, right? The mistakes that can happen in such setup, a large scale setup. So what we would want here, we would want the VTAPs to communicate with each other, exchange the VLANs or VNIs that have been configured locally, so that other VTAPs can dynamically populate all the VTAPs in the flood list. So if VTAP 2 says that, hey, I have VLAN 10 and 20, then VTAP 1 can say, I also have VLAN 10 and 20. Let me add you to my flood list, right? Similarly, if VTAP 3 says I have only 10, then VTAP 1 can add VTAP 3 in VLAN 10's flood list and need not put it in VLAN 30's flood list, right? But the main thing that we see here is, again, communication that needs to happen between the VTAPs, right? Any doubts or any questions so far? Okay, I'll move on. A little slightly off topic. So this is the issue 3 that I would want to discuss. This is a BGP setup for all the BGP lovers who are out there. So you have AS where you have say 10 or 20 routers, right? And they are not directly connected. All these routers are indirectly connected through multiple other hops in between. But the requirement is that you form neighborship between these routers and exchange the routes, right? There might be, say, behind R4 there are some routes, uh, some networks behind R1 there are some networks. In between can be OSPF, whatever IGP that we can think of running. Now the requirement is how do we exchange routes between R1 and R4 or R1 and R2, R1 and R3, R1 and R10, and so on. What needs to be done? What would be the easiest and most efficient way of doing it? Anyone?
A routing protocol.
Okay, so we are going to run. We want to run, like, there is in between there is IGP, right? But we want to run BGP between, like, we want to there is BGP running on R1, there is BGP running on R4. Okay, how do R1 get all the routes from, like, you have a lot of routers, right, in this topology. I just took 10 as an example. There can be 20 as well. But the idea is that how does R1 get BGP routes from all these devices, from all R1 to R10?
Either we can establish a neighborship between everybody, or we can have a route reflector to distribute the routes across.
Correct. You're right. So we can establish neighborship between R1 to R2, R1 to R3, and so on, R1 to R10, right? Similarly, R2, like, every router needs to have a neighborship with every other router, right? There is some formula to tell the number of neighborships, but overall there'll be a huge number on each and every router. There will be like 9 neighborships, correct, to manage. So what would be the easiest way? I think you already mentioned it. So what would be the easiest way to efficiently configure this such setups?
We use route reflector or route
We
server.
can use route reflector, right? So if we have route reflector, then all these routers, all 10 routers needs to form neighborship with just one device, and then they can exchange the information, right? They can exchange the prefix, they can exchange the route, correct? So that's right. If we have route reflector, it makes it easier. We just need all 10 devices, all 20 devices just need to have one neighborship, and they can get all the prefixes, correct? So if you look at this, right, in this setup that we have spoken about, we saw certain issues, right, with in terms of yeah. So we saw certain issue in the VxLAN environment, right? What we saw an issue where the MAC is not learnt on all the VTEPs, which causes flooding of traffic, correct? We see that when a lot of VTEPs are to be configured, then we have to do a lot of configuration. It's a configuration overhead, correct? And so what is our requirement? We want a solution where each and every VTEP can exchange the MAC that are locally learned on that VNI and with that VTEP IP. So if there is VTEP1 would want to take the MAC address, associate the VNI where the MAC address has been learned, and say that, okay, this is my VTEP IP, and if you want to send traffic for this MAC, come to me. Similarly, VTEP1 would want to tell to all the other VTEPs, so this is my VTEP IP. These are the VNIs that have been configured on me. If you want to flood a traffic, flood it to my this IP, right? So we want a solution where these information can be, we would want these information to be exchanged, right? Now, taking some inspiration from the previous, the way BGP is doing, what can we do here we have a lot of information to exchange. So what can we do here to exchange that information?
EVPN.
Sorry?
EVPN.
EVPN. Correct. Yes, so EVPN is one solution, but I would not want to go there. But my idea of here is what is the role of route reflector here? When we spoke about BGP, what was the role of route reflector?
Maybe
Yeah,
Sorry.
maybe we need a device that can which can basically act as a solver that
Correct.
gets all the information and then publishes it back to whoever is subscribing to it.
Yes, yes. So basically, if we think about the way BGP is handling such information, right? When you have huge scale of information, how and we have a lot of neighborships to be formed and exchange routes. What BGP we do in BGP? We put something centralized, right? We would have say route reflector or say spine, which is acting as something central, and we exchange a route through that particular device, right? We route reflector acts as a server, which would take prefixes from all the devices and send it to all the other routers, correct? So Kushal was right. Yes, in this case as well, if we can have some kind of server that can take all this information from all the VTAPs and publish it to all the other VTAPs, it will help us solve the problem, right? So that's the solution here. That's what we would want here. The simplest way of doing it here is that having some kind of server that can establish the way route reflector establishes a session with all the other routers in the AS, establish sessions with all the VTAPs, right? Once it establishes sessions with all the VTAP, we want that server to get all the locally learned MAC address of all the VTAPs, okay? Create a database out of it, and then similarly get information of all the VNIs that have been configured on this VTAPs. Again, create a database out of it, and then just propagate this information to each and every VTAP in that set where it has been, with whom it has formed the sessions, right? So if we have a server in this scenario, it makes everything easier. Just tell whatever I have learned locally to that server. That server will tell it to all the other devices with whom the server has formed the neighborship. So simplest way of solving this problem or achieving this requirement is having a server setup. Is that clear? Anyone has got any other solution for it apart from the server that Kushal came up with? Okay. So this is what we are going to today talk about. We have certain requirements. The requirement is to exchange MAC addresses, even if traffic is not being received, right? The requirement is to exchange the VNIs so that a flood list can dynamically be populated, right? And just move away from the dependency of configuring flood list through CLI, or move away from the dependency of learning the MAC once the traffic has come on the VTAP, right? This all can be done if we can exchange this information. So Arista was pretty smart. We thought about these issues long back, even before EVPN came into picture, and for people who know about it, but we thought about it long back, and we came up with a solution called Cloud Vision Exchange. So the server that we are talking about here is called Cloud Vision Exchange, right? And that's the solution from Arista to achieve the requirement that and the issues that we spoke about earlier, where Cloud Vision, which is a server, would act as a single point of exchanging all this information between VTAPs. So Cloud Vision that it actually came in very long way back, I think 2014 or 13. It might have come even before that, but it was there back in 2015, I'm sure. So what is Cloud Vision? Cloud Vision is basically a server that would exchange MAC addresses between the VTAP. It will exchange all the VNIs that have been configured on the VTAPs so that MAC address can be populated dynamically, and even the flood list can be populated dynamically, right? So what we are talking about here was just one use case of Cloud Vision, where we took VxLAN as an example and the issues that we are trying to solve with VxLAN regarding VxLAN, and we use Cloud Vision, which is a server to address those issues. But Cloud Vision can also be used. We have other solutions as well with Cloud Vision to basically integrate integrate with other vendors. Say if you want to integrate with NSX, if you want to integrate OpenStack, all those things is possible through Cloud Vision. But one of the popular use case of using Cloud Vision is to exchange MAC addresses, exchange VNIs locally configured and dynamically populate the flood list. Now, if we talk about Cloud Vision, what is Cloud Vision? Actually, Cloud Vision is not, it's just a EOS instance that is deployed somewhere as a VM. So generally we can deploy the Cloud Vision on either ESXi or KVM. And basically when we have Cloud Vision, which acts as a server, all the other VTAPs or switches would act as clients. So you have Cloud Vision server, you would have all the VTAPs or switches acting as a client, and then they would exchange this information with each other through Cloud Vision server, right? And the final thing is that since I said Cloud Vision is nothing but a VOS, what you would see is that in a setup, you would have the Cloud Vision, which is a VOS, would have the same EOS version running on it, and all the VTAPs would also generally have the same EOS version running on it. So let's say if Cloud Vision is all the VTAPs are running 427 version, then Cloud Vision, which is also a VOS, would be running 427 version. So it's nothing but just a VOS. So we'll see what the CLI is, how can we configure it, but the look and feel is just same as a EOS CLI. So that's how I wanted to start today's topic. It's Cloud Vision. So we would be discussing Cloud Vision Exchange implementation with VxLAN. How does it help us to solve the problems that we discussed earlier? Any queries before I move ahead about anything that we have discussed so far? Okay, so this is what I want to give an overall picture of what Cloud Vision is doing here. So the same setup where you have VTAP 1, VTAP 2, VTAP 3, all of them have their own MAC addresses that has been learned locally. So H1 has learned on VTAP 1 on Ethernet 1, H2 has been learned on VTAP 2 on Ethernet 1. Similarly, H3 has been learned on VTAP 3. So what we can do is each and every VTAP can talk to a server, let's say Cloud Vision Exchange, the CVX we call it, and publish this information to that particular server. And then this information can be exchanged with all other VTAPs, right? Same thing goes with the flood list for population of flood list as well. If VTAP 1 can tell that, hey, I have VNI 10010 configured on me, if VTAP 2 can say the same thing, VTAP 3 can say the same thing, we can create a flood list information here, where you have 1.1.1, 2.2.2, 3.3.3, all have the same VNI, and you can just send it to all the VTAPs. And this would help all the VTAPs to dynamically populate the flood list, because now we are exchanging this information. We are exchanging the MAC address, we are exchanging the locally configured VNIs. And this is the simplest way of saying what Cloud Vision does. Cloud Vision Exchange, I should say, sorry, which is CVX. Any questions on what Cloud Vision does, what we are trying to achieve here?
Sorry, Sachin, one question.
Yeah.
Would CVX have the VLAN to VNI mapping also?
No, CVX is just a server. It does not need anything, right? Its job is to just receive all the information and publish it to everyone else. CVX is nowhere in the path of data plane, just like route reflector. If you think about it, right? Route reflector need not be in the data path, right? The route reflector's function is to just exchange the routes. Similar to that, CVX functionality is to just exchange information, which is MAC and VNI, so that the VxLAN address table can be populated dynamically, same, and then the flood list as well.
So
yeah.
Sorry, continue.
Go ahead.
No, so that means we have to make sure that the VLAN to VNI mapping is same across all the VTIPs.
Yes, correct. That we need to make sure. Yes.
Okay.
Because that issue can also be there with static, right? I can, when I
Yeah.
have static configuration, I can have VLAN 10 to same VNI, VLAN 20 to same VNI, 30 to same VNI, right?
Yeah.
So that at the end of the day, when you have VXLAN environment, we are concerned about VNIs. We are not concerned about the VLAN to VNI mapping is local, right?
Mm.
So that's why here I have put the VNIs here. So the information that is published is for VNIs, not, of course, which is internally mapped to a VLAN, but
Mm.
it's all published for a VNI.
Okay. Thank you.
Yeah. And another thing that you would see here is that I have put MA1 here for communication between VTAPs and Cloud Vision Exchange, CVX. So generally what we would see is that Cloud Vision is deployed somewhere in the management network, and the reachability to this Cloud Vision is through our management interfaces. But that does not limit us to just management interface. Cloud Vision server can also be configured, like connected locally on the VTAP, and then again advertise the routes and make sure that there is connectivity. But generally, you would see that server to be deployed in the management network. But depends on customer deployments. Any other doubts?
Sorry, Sachin, I have to.
Yeah.
So how could the is it like Cloud Vision manually configures in the devices, or it runs a protocol negotiation between the devices?
Yes. So the configuration part, I'll come to it.
Okay.
Again, you can think about configuration similar to an route reflector itself. At the end of the day, even if you want to exchange routes between R1 and R10 through route reflector, you would need to have neighborship IPs configured for route reflector, right? The same here as well. On VTAP 1, you need to define an IP address for CVX. On VTAP 2, you need to define an IP address for CVX. On VTAP 3, you need to define IP address for CVX, so that they can go and talk to that CVX.
Okay.
We'll come to the configuration part. How do we configure it? But yes, we need to configure it. There is no automatic discovery of CVX in the network.
Okay.
Any further doubts? Okay, so before we jump into the CVX solution for VxLAN, I wanted to also take a moment to talk about the different things that we can do with CVX. Okay, we would not deep dive into any of these except the VxLAN solution that we were discussing earlier. But CVX not only provides us a way to exchange MAC addresses, but there are other services as well that CVX provides. So here are some of the services that CVX provides. So first one that we see is the VxLAN service, which actually helps the VTAPs to exchange the MAC addresses that has been learned locally and the VNIs that have been configured locally, so that dynamic flood list can be populated. So that's the VxLAN controller service. The other one is called the hardware switch controller service, which is basically for integration with the Open vSwitch database. Generally, what we would see is that if you want to integrate the NSX setup with the existing VxLAN setup, we would use CVX to communicate between our hardware VTAPs and the NSX. So when we talk about NSX, generally in NSX you would have a lot of software VTAPs. So they are not hardware, but there will be VTAPs deployed in the servers, which will be software. So we would want to have the MAC addresses that are learned behind the software VTAPs to be populated in our Arista switches as well, right? So the CVX controller acts as a single point where we could exchange the MAC address that are learned from NSX or Nuage, all these solutions which provide software VTAP to hardware VTAP. So that's one more solution that we give, hardware switch controller. The other one is called macro segmentation that is called MSS, where we can talk to, say, a firewall. It can be Palo Alto, Fortinet, or Checkpoint as well, and we can take whatever rules that they have. Say that this, let's say they say that deny this traffic. Then what we can do is we can install ACLs on our devices so that we can drop the traffic even before we send it to the firewall. So we can have communication between firewall and the switch through CVX, so that we don't have to send traffic to firewall to drop it, rather than it can be dropped on the switch itself. So that's another solution that we provide, which is called macro segmentation. Sorry. Other thing is OpenStack service, where again we can have dynamic VLANs deployed on our devices through OpenStack, where let's say you configure a VNI on the OpenStack dashboard, and it will automatically deploy all those VNIs on our devices as well, on the VTAPs. And the final thing that we provide is the network topology service, where once we configure or connect all the VTAPs to the CVX, it will automatically learn all the connected LLDP neighbors. So if we have connected VTAP 1, VTAP 2, and VTAP 3 to CVX, all the information of the local LLDP neighbors would be sent to CVX, and you can see the entire we can see all the connected devices through CVX, because each and every VTAP would send its LLDP neighbor to LLDP information to CVX. So these are some of the services that are being provided by CVX. There are a couple of more that I have not listed. There is one where you could have a controller to basically statically push static M routes into the switches. That is another. Very recently it came in. Media controller service, we call it. So basically CVX acts as an integration point for any service. If you want to integrate with NSX, if you want to integrate with OpenStack, if you want to integrate with some kind of external controllers, third-party controllers, then CVX becomes a central point of communication with our VTAPs or switches. So what we are going to talk about today will be the VxLAN controller service, also known as VCS, which will help us exchange MAC addresses and the flood list information. Any doubts regarding the different services that is provided by CVX? I just wanted to show you what are the different services. Now, if you look at this particular slide, basically how do we configure that? Okay, I want to have the VxLAN service running on the CVX, right? So we talk about different services that can run. We can exchange MAC addresses between VTAP. We can exchange MAC addresses from NSX. All these things are possible, right? So what we are going to discuss here is the VxLAN service, which will help us exchange MAC addresses between VTAPs and the locally configured VNIs to populate the flood list. And how do we do it? It's very simple. We go under the CVX, we deploy CVX. I'll just show you what do we do to deploy CVX. But I wanted to show you the different services that are available. Once we deploy CVX, we go under CVX config mode, do a no shut to enable CVX. And then if you do service question mark, you would see all the services that are available for us to use. So this is the VxLAN controller service, VCS that we're going to use. And what we would need to do is do service VxLAN and just do a no shut. And that would at least, and it will just enable the service VxLAN. And then we need to configure VTAPs to communicate with CVX so that they can exchange the information. So this is the different services that we have, and then we need to configure VTAP to exchange information with CVX. Any doubts so far? Okay, fine. So let me just quickly talk about how do we deploy it. Actually, the steps are pretty simple. So first thing that we would need to do is, as I mentioned earlier, the CVX can be deployed in ESXi or KVM. So what we would need to do is go to our software download page, and then go under Cloud Vision, and then under Cloud Vision you would see Cloud Vision Exchange, and then go to the release. So as I mentioned earlier, CVX is nothing but EOS, right? That needs to be deployed as a VM, and you would need to download the relevant VOS version. So as I mentioned, if you have all your VTAPs running, say 427.1, the recommendation is to have the CVX also running the same EOS version, which is 427.1. So in my setup, I deployed all the VTAPs with 427.1. So I will just download, say, the OVA file, which is used to deploy CVX on ESXi, or QCOW2 file if you want to deploy CVX on KVM. Download it and then follow the steps which has been mentioned in our config guide. I do not want to go through that because all we would need to do is just upload the file, and it's just basically next. Configure the allocate resources, 4 GB RAM, say 4 GB hard disk. There are some minimum requirements that has been mentioned here, but allocate those resources and just spin up the VM. It's similar to the way how you deploy the Eve on Eve VOS, right? Configure that, give the amount of RAM, give the amount of hard disk space, and just deploy it. So it's exactly similar, but here we are generally it's deployed in either KVM or ESXi. Okay, so now we spoke about how CVX can be used to exchange this information between the VTABs and basically resolve the issues that we spoke about so far, right? Now I have another issue for all of you, right? Now when we have CVX in your setup, right, and what you're doing, you're using CVX to exchange the information, whatever MAC has been learned on the local VTAPs, you are using CVX to exchange information. Now when you have CVX, or when you have route reflector, if again taking BGP as example, what would happen if the CVX goes down, right? It becomes a single point of failure, right? Too much dependency on one device or one setup causes it can cause catastrophic effects, right? Because now you, instead of VTAPs relying on like MAC address learning from from data plane, right? We are now relying on a controller to tell us the MAC address. So what if the controller itself goes down? And that becomes single point of failure, right? So what can we do to avoid that, or how can we avoid a single point of failure?
Have CVX in the cluster, multiple servers.
Yes, you're right. Have CVX or deploy more number of CVX, right? The way you have route reflectors deployed in a cluster, we would also want to have CVX that is also deployed in a cluster, correct? So yeah,
just taking a note that CVX is basically a VEOS.
correct. Yes.
And we maybe like make one of the VTAPs as a point of maybe redundant something.
So actually, long back in 4.16 code, we used to support the hardware switch itself to act as a CVX, but now we don't support that. So you cannot configure a switch itself as a CVX. Because then you run into resource constraints, right? Let's say you need to give certain amount of like dedicated RAM, dedicated hard disk space for CVX, right? Now if you are using the same thing as on the switch as well, that would also be a problem, right? Switch also becomes a single point of failure.
That would make it that would cause overloading the VTAPs.
Correct. Yes, you're right. So it's easier to just deploy US as a VM somewhere and use that as a CVX. So that's why we stopped it. If you configure, like if you go to a 4.16 code device, you would be able to configure this like this. You would be able to do this on a 416 code switch, but in your code it will not allow you to do it. That is after 460, I think, 470. Okay. Anything else, Kushal?
Just that. Thanks.
Okay. Okay.
Always good to add that history.
Yeah. Thanks for asking. Okay. So Akshit was totally right. We should deploy CVX in a cluster, right? That means we need to have capability to deploy CVX in a cluster, right? When you have more than one device that is acting as CVX, they need to talk to each other. They need to sync states between each other. Also, they need to make sure that even if one goes down, other is taking over, right? So the idea is to deploy CVX in a cluster so that you have redundancy even if one goes down. So we support the same. We also support deploying CVX as a cluster. Now, cluster of how many depends on okay, so cluster of how many depends on a formula. So basically in CVX we call deploying CVX in a cluster is called high availability. Generally CVX is deployed in a cluster of n2 n plus 1. Okay, so basically CVX can be deployed as a single node because 2n plus 1, like n is 0, so it can be single node CVX. It can be 3, it can be 5, it can be 7, 9, and so on, but it needs to be an odd number. Now when you have CVX as a cluster, it can be, let's say, CVX cluster of 3 nodes, then one would become master and other 2 would become standby nodes. So one would become master, other would become standby node, and let's say if the master goes down, then one of the other two nodes would become the master. So in a cluster of 2n plus 1, let's say if you have 3 clusters, that means 2 into 1 plus 1. At max, you can tolerate failure of one node. So now think about this way: if you have 5 devices, so you have cluster of 5 nodes, one of them became master, right? So if one of the nodes goes down, which was the master, then in the remaining 4, you can have one of the nodes that will become master. Okay, even that node can also go down. You still have 3. 3 is like you have majority, right? So one of the remaining 3 nodes can become master. Now, if the third node also goes down, then there would not be any more master, because now you do not have a majority. You only have 2 nodes and there is no more majority. Then the CVX would cease to exist. So that's why in a cluster of 3, you can have maximum failure of 1. In a cluster of 5, you can have maximum failure of 2, because you need to have 3 for majority, right? So as long as there is a majority, let's say if there is cluster of 7, then you could have 2 into 3 plus 1. So you could have at max 3 failures, because even if three nodes fail, you still have 4, which is a majority, and between these 4 you could have 1 master and remaining 3 would be standby. But if 4 nodes fail in a cluster of 7, then there would not be any more master. The cluster would cease to exist. So this is a way we make sure that the reason we are doing this is because we need to make sure that there is never a situation where you have 2 masters. Let's say, for example, if I had a cluster of 3 and all of them, they are not able to communicate with each other, right? If we are still able to have a master with 1 node, then you would have 3 master in the setup, and that could cause even major problems, say out of sync databases, because not all VTAPs might have communication with all the nodes. So to have majority, to make sure that there is never a master situation or more than 1 master, we make sure that there is always majority when selecting a master. So one would become master and the remaining would become the standby. So any queries about how the CVX high availability is deployed?
But the operation is only performed by one master, right? The backups are just purely just backups.
Can you repeat? Sorry, I did not get the question.
So in a cluster of 3,
Yeah,
there would be 2 backups and 1 master, right?
correct. Yes.
So everything would be handled only single-handedly by master. There won't be anything on backups.
So actually what happens in backups also have everything, because what we do is on the VTAP, we give that, okay, I'll show the configuration on the VTAP. We say that, okay, these are the 3 CVX nodes that are there in your network. So what VTAP does is it tells all its locally learned MAC addresses to all the 3 VTAPs, but only master gives the advertises the information, but the backup would just keep it, so that
Okay.
if the master goes down, they can start exchanging the information.
Got it.
So information is sent to all the 3. Let's say if you have a 3 node CVX cluster, then all the VTAPs would send the information to all the 3 nodes, but only master would exchange it with other VTAPs, and the standby would just keep the information and wait for them, wait to become master, so that they can start exchanging the information.
Sachin, I'm
Yeah.
still, what is the harm if I'm having in a cluster of 3,
Yeah.
1 CVX went down, I'm still having 2, right?
Correct. Yes.
So I'm still having redundancy. So why don't we use that?
So 2 can become, you have majority, right? In a cluster of 3, 2 is a majority, right? So you can still have 1 master between 2.
Okay.
Okay.
And then in 7, you said if I am left with 4, the CVX will not work, right?
No, 4 is fine. Again, majority is in 7, 4 is a majority, right?
Okay.
But if less than 4, then there would not be any master.
Okay. So my question is there.
Yeah.
If I'm having out of 7, I'm having 3. Still, I'm having 3 CVX to serve. So
Correct.
why don't we use that?
Because let's say if you had 7, and let's say 4 are able to communicate with each other, and remaining 3 are able to communicate with each other, but 4 and 3 are not able to communicate with each other, you would have 2 masters, right? You get it?
Means that can be anytime, actually. If
No,
there are 4 or 5 also.
no, it cannot happen, right? If you look for that majority number, then you would always have 1 master. Let's say if you have 3, okay, if you have 3 nodes, and let's say 1 went down, so it became separate, okay. So it will say that my majority number is 2. I'm separate, so I would never become master. Okay. The remaining 2, they would say, okay, we still are in majority, right? 2 people out of 3, correct? So they will choose 1 master between them.
Yeah.
But now let's say those 2 also stop to communicate with each other, then all 3 nodes are individual, right? They're not able to communicate with each other. So they would say that we cannot be masters, because you don't know where is the majority, right? If all 3 become master, the problem is that then the sync can be incorrect, right? Because let's say CVX1, CVX2, CVX3 are not able to communicate with each other, and let's say some VTAPs are able to communicate with CVX1, some VTAPs are able to communicate with CVX2, some are able to communicate with CVX3. If all of them are master, then the information will be totally wrong. Flood list will be all messed up.
Correct.
That's why we make sure that only if you have majority, one can become master, and then majority makes sure that majority is a way of making sure that the setup would only have 1 master.
Okay.
Yeah, even if you take 9, do any math, you need at least 5 to become you need to have a master, minimum 5. So it's like a math that we are doing to make sure that there is only 1 master in the entire setup. It's the easiest way to figure out to make sure that there's no split brain kind of scenario. I was just doing the math. Any doubts about it?
Sorry, Sachin,
Yeah.
one question. So in the scenario that Naveen mentioned, where or actually which you mentioned, where all three CVX are not talking to each other,
Yes.
but the switch can, I mean, the VTEP can still reach the CVX. So would the VTEP know that CVX is down?
So VTAPs would know that the other two CVX, like let's say, the question is, are all VTAPs able to talk to all CVX, right?
Hmm.
Let's say if all VTAPs are able to talk to all CVX, again, the network generally works in worst case scenario, not in the best case scenario, right?
Yeah.
We design our networks in worst case scenario. Let's say only few VTAPs are able to talk to switch one, sorry, CVX1. Few VTAPs are able to talk to CVX2. Few VTAPs are able to talk to CVX3, correct?
Hmm.
If all of them become master, their flood list, their MAC address learning would all be totally incorrect.
Yes.
So that's why we do not elect master if there is no majority.
No, my question is, would VTEP know that there is no?
Between the what do you say?
The CVX cluster.
Yes, VTAP would know, because VTAP has the information who is the master.
Okay. Okay.
Yeah, like that information is there with VTAP. Like once, like again, we'll check the outputs. I'm running out of time, so I'll most probably stop here after just showing you the next slide. But what VTAP would do is, once CVX communicate with each other, CVX1, CVX2, CVX3, and they say CVX1 is the master. Similarly, the VTAP would also communicate with CVX1, CVX2, CVX3, and they'll get this information from CVX saying that, hey, CVX1 is the master.
So even in that scenario, it will still sync all its data with all the three CVX or just with the
Yes.
CVX master?
It will sync with all the three CVX, but then it will only receive information from master.
Master. Okay.
It's like you're making sure that the other two are, let's say if it's 3-node cluster, you're making sure that other two have the information in case anything bad happens.
Okay.
So you send it to all of them.
Got it. Thank you.
Okay. Any more questions?
Is there a special communication between master and backups?
There is communication, but unfortunately we would discuss
Ah,
next week.
Okay.
There is actually, what I wanted to do today is just to show you how does it work, and then the internal working, the later part, but I think we could not reach there as well. But this last slide I wanted to show you, how do we configure CVX, right? So on the CVX, like earlier what we did, we enabled this, we enabled the VxLAN service, right, to exchange MAC address and flood list. The next thing that we would do is on the CVX, so for each and every CVX, tell what is my peer. So you would go under again the same CVX node. We had already done the notion, and then they say that, hey, your peer is 192.168, sorry, 10.85.128.182. So here this is a 3-peer cluster. This is how they know that the number is 3. Like even to do math, they need to know, right, how many are there in the cluster. So based on the configuration, each CVX node knows the number of nodes in the cluster. So once you configure this, all the CVX would become, they would form a cluster. So this becomes cluster of 3. And then on the, this is last, and then on the VTAP, you would do this configuration. On the VTAP, by default, you have MAC address learning via the flood, via CLI, right? Sorry, via data plane, right? You get packet with a MAC address, inner MAC address, you learn it. And you have to configure a flood list as well, right? Statically. So what you would need to do on VTAP is run this command, VxLAN controller client, and then under management CVX, list the CVX nodes. So in my case, 10.85.128.181, 182, 183. So you configure this. Once you configure this, that's it actually. That's the configuration on CVX and the VTAP. So on the CVX, you tell all the nodes if it's in a cluster, and on the VTAP, you just list the CVX nodes. So like, as I mentioned, like in router FAT, you need to form neighborship, right? So there's no auto discovery. So you need to go under management CVX and list the CVX nodes. Any doubts? So that's all. Actually, I would not proceed further for today, but that's what I want to discuss.
Thank you so much, Sachin. So definitely the way you started and discussed the need of such controller, that was amazing, right? Otherwise, we don't get such information why we are doing so much complicated setup we have and all that. So I think now we appreciate why CVX cluster is needed. Thank you for that. So we will look forward for your second session. Thank you.
Sure. Thank you. Thank you so much, guys. Just reach out to me in case you have any doubts.